Alright, so here we have Ryan's polynomial function, and what we want to do is to factor this function down to its most simplest form so we can graph it. So what we need to find are factors that will go into -4 and +2. As you can see, I've written plus and minus 1, plus and minus 2, plus and minus 4, as well as on the denominator, plus and minus 1 and plus and minus 2. Now when we plug in some of these, one of these values into the equation, we need to see if that will make our polynomial function equal to 0. So as you can see here, I've plugged in +1 to start off with. And as a result, after doing all the calculations, it equals 0. Now that's what I want, because now that I know that it equals 0, I can use 1 in my synthetic division. So I take the coefficients of my original polynomial, which is 2, 7, -5, and 4, and I just simply go through the process of synthetic division. I bring down the 2, multiply 2 times 1, which is 2, the 7 and 2 is 9, -5 plus 9 is equal to 4, and then -4 plus 4 is equal to 0. So that's what I want. I'm happy now because I can take my coefficients now, my new coefficients that I have, 2, 9, and 4, and I want to bring down the x by one exponent. So it'll give me 2x squared plus 9x plus 4. And I also can't forget that 1 that I used to divide, so that would just be x minus 1 as the correspondent. Now I need to take my new polynomial and factor it even more by decomposition. So I need to find two numbers that multiply to +8 and add to -9, and those numbers are 8 and 1. So now I can expand out my new polynomial, which will give me 2x squared plus 8x plus x, and then plus 4 on the end. Then after factoring out a 2x, that leaves me with x plus 4, and then plus 1, and then x plus 4 again on that. And now I have my, I'll just clean that up a bit, make that as 2x plus 1, and then x plus 4. And now that gives me my x values. So that means that x is equal to -1/2, -4. But you also notice we also need to bring down that x minus 1 into our final step, because we can't forget about it. So that also means that our x value is equal to 1. So now in order to find the y-intercept of this graph, it's pretty simple. We just set x equal to 0. So as you can see, I'm writing out in the steps here, 2 times 0 cubed plus 7 times 0 squared minus 5 times 0 minus 4, which is equal to ultimately y equals -4. So now I know my y-intercept, and now we'll skip ahead to the graph here and we'll start plotting some points that I've now figured out. I have my y-intercept down at -4. I also have my x values at -0.5, +1, and -4 as well. Now if you look back to the original polynomial, my highest degree is 3. Therefore, I know that the graph opens right up and left down. Now, if that 2 was negative in front of, or if it was -2x cubed, then it would have opened left up and right down. But because it's positive, I know right up, left down. I also know the maximum number of turning points is equal to 2, which is just simply the degree minus 1. So that makes it easy. So now I know the amount of turning points. So now I start plugging in my values because on my graph I am missing -1, -2, and -3. So I plug in all my values to figure out where my corresponding y's are in that equation. You'll note I wrote p of x and I should have wrote p of -1, p of -2, just a simple mistake. But as we now plot the corresponding y coordinates on the graph, now I'm entering my final step and I just simply graph the function. I start down at the bottom, connect all the points going through the y, coming up, back down with the 2 turning points as I stated, and that is my completed graphed polynomial.